Hello everyone, how are you going? I hope that you all have a well-rested break. And for this term, we are actually doing measurements and geometry. Prior to this, we can see that this is chapter 60. So prior to this, hopefully you have done revision from 6A to 6C. So this will cover converting units, different units, and also the Pythagoras theorem, and also finding the areas of different 2D shapes. Yeah. So today we are actually doing the surface area of prisms and cylinder. So what is a prism? Prisms have uniform cross-sectional areas. So the two ends are actually congruent. So I've drawn a few samples of prisms, and I have actually made the front of each shape the cross-sectional area. So as you can see, the front and the back of each shape, they are actually congruent. The meaning of congruent means that it has both the same shape and the same size. So if we look at cylinders, we know that cylinders have uniform cross-sectional areas as well, and that the two ends are circles with the same diameter. So this is one sample of a cylinder, but they are practically almost the same. So next, we are learning total surface area. As a shortcut for future use, I actually put TSA. So TSA will mean total surface area in future. Yeah. So the first thing we are doing is to find the TSA of a prism. So let's start with a very simple one, a rectangular prism. Yeah. And given the dimensions below. Yep. So the first thing that we can find is actually the area of the front, which is pretty easy. You just times 2 with 7 and you get 14. The area of the left side is 2 times 5, which is 10 centimeters square. The area of the top, which is 7 times 5 centimeters, which is 35 centimeters square. So if we are considering total surface area, we are actually considering all the areas that are exposed. We know that the front and the back are congruent, and therefore we can times the area that we got for the front, which is 14 centimeters square, by 2, and we get 28 centimeters square. The area of the left and the right are congruent, and therefore we are timesing 10 centimeters square by 2. So 10 centimeters square is the area of the left side. Okay, and we also know that the top and the bottom are congruent, and therefore we times 35 centimeters square by 2 to get 70 centimeters square. So this will mean that our TSA will be 28 plus 20 plus 70, which is 118 centimeters square. So there is also a shortcut to it. So if we can identify for a rectangular prism, yeah. So if we can identify the unique areas that a rectangular prism have, it's definitely there are 3 unique areas. So if you get either the front or the back, one of the sides, and the top or the bottom, you add them up and times them by 2, you will get 118 as well. And that means that you don't have to do this lengthy process over here. Yeah. And yep, TSA for a cylinder. Yep. So for example, if we have an exercise to find the total surface area of the cylinder below, yep. The first thing we need to understand is the area and the circumference of a circle. So the area of a circle is pi r squared. So that's the formula. So if you actually substitute 7 in this situation, our radius is 7. Yep. So this circle is actually the bottom of the cylinder. So pi 7 squared will give us 49 pi centimeters squared. And the circumference of a circle is actually a pi d or 2 pi r. I'm using 2 pi r here. So pi d, d is actually the diameter. Yep. So 2 pi r over here. So 2 times pi times 7, which is 14 pi centimeter. So in this case, a circumference is actually a length. So the unit will be just in centimeter. So if I actually open up the cylinder, it actually has a net that looks like this. Yeah. So if we actually focus on just the curved surface of the cylinder only, yeah, we know that the circumference of the circle is equivalent to the length of the top side of this cylinder. Yeah. In order to get this area of this rectangle, we actually need to times the length, which is 2 pi r by 10. So that's what I'm doing. So the area of the rectangle will be 2 pi r times 10. So 2 pi r, because my radius is actually 7, so this will give us 14 pi times 10, which is 140 pi centimeters square. So this will be the area of my curved surface of my cylinder. The area of the two circles will be 2 times 49 pi centimeters square, because 49 pi centimeters square is for one circle. I times it by 2, and therefore it gives me 98 pi centimeters square. The TSA for a cylinder will be 140 pi plus 98 pi. So this will give us 238 pi centimeters square. So if we have a question to find the TSA of composite solids, yeah, we have to again understand that TSA is all the exposed surface, yeah. So if we are looking at the exposed surface, which are the exposed surface? Let's just do it step by step. So let's just consider the rectangular prism below, yeah. The rectangular prism below, as we have done before, will have the area of the front and the back will have 2 times 2 by 7. So this will be the front and back. So that's 2 of them times 2 times 7, which is 28 centimeters. The area of the left and right, which is 2 times 5, yeah, which is 20. And the area of the top and the bottom, which is 2 times 7 times 5 centimeters, which is 70 centimeters square. So if we consider the area of the curved surface area of the cylinder, it's going to be what we have done before. So this is 2 pi r times the height. So in this case, the radius of my circle is just 1. So I have here 2 times pi times 1 times 3 will give me 6 pi centimeters square. This is the area of the curved surface. Yeah. The area of the circle will be pi r squared, which is pi 1 squared, which is a pi centimeter square. So the area of the circle will be the top part over here. Okay, to find the TSA of the whole composite solid, we have to add what we have found for the rectangular prism first. So I have actually color coded this as the red one here. Okay, minus plus with the area, the total surface area of the curved side of the cylinder and one area of a circle. Yeah, so this is right here. And then you have to always remember to take away the part that is covered, that's in between here. So this pi centimeter square is actually the area of one circle, and this circle is the part that's joining the cylinder and the rectangular prism. So this cannot be counted. We have to take them away. So once this is done, we can find the TSA of this composite solid as 118 plus 6 pi centimeter square. So I would advise you to leave your answer this way, unless you are asked to round your answers off in 2 decimal place, and then you can round it off using your calculator. But this is a preferred method because this actually shows us the exact value of our area. So that's all for today, and happy studying at home, and yeah, I'll see you next time. Bye.